I was having a look at, from time to time I have a look at what I film, and I noticed a couple of sessions back I made an embarrassing error. I was talking about an alphabet, thinking of it as a set of strings. Now that was the wrong term. So I mean, I should have said a language. A language by definition is defined as a set of strings. So I was consistently making the same error. So I'd like to point out, and I've done this several times in earlier courses, I make mistakes. Okay, so be cynical, be wary. Not everything I tell you is the gospel truth. So pay attention. I make errors. I commit, as the Americans say, thinkos, which is sort of similar to a typo. When you're typing and you type the wrong key or something and the wrong letter comes up, well, that's a typo. And thinko is sort of analogous. You're constructing sentences in your head before they come out, and for some reason the wrong word comes out. Okay, so a couple of sessions back, when I'm talking about an alphabet this and an automaton is an alphabet detector, garbage. Right? I should have said language. An automaton is a language recognizer. Okay. Now the next board, next 4 sessions. For the first session, or 1, 2, 3. So for the next 3 sessions, we will continue, in effect, analysing some automata, and then in the 4th session, we will begin the process, the opposite process, and that is synthesizing or designing or creating a automata. Now that's more creative, it's more difficult, so it pays to learn how to analyze first. And so you have when you analyze an automaton, you're given the automaton. You're given either the formal definition and or the more informal state diagram, or to use the longer term, state transition diagram. Okay, and then you try and figure out what the function is of that automaton. What's its job? In other words, what's its language? What strings are accepted by that automaton, and all the strings that are accepted, you put them into a set. That set's called a language, and the automaton is said to recognize that language. So when you hear that phrase, an automaton M recognizes a language L, capital L, what that means is that every string in that language, in that set, is accepted by the machine. Okay. Now it's assumed every possible language. Here we go. Every possible string is in that set. Right? It's not the case that there will be some strings that would be accepted by the automaton that are not in that set. It's assumed that the set of accepted strings is complete. Okay? There's none left out. That's implicit. I don't think the text has made that explicit, but it's sort of obvious if you think about it. Alright, so we will do, let's see, how many more examples? So the 1, 2, 3. So we'll do, in the coming few sessions, we'll do 3 more examples of automata and analysis. And in the 4th session, we'll start on a more difficult process, more creative, open-ended challenging process of synthesizing, in other words, constructing, or what's the term they use? Designing finite automata. And that goes on for quite a few sessions after that, so next board. Right, so let's start with, we'll do 2 in this session. We'll do 1 completely and then start on the second one. 2 automata and analyze them. You figure out, what does that mean exactly, to analyze an automaton? Basically, you figure out what its language is. In other words, what kind of strings get accepted by the automaton. Right? So in that sense of analyze. Okay, so here's now remember when you're analyzing an automaton, it's given to you. Right? How can you analyze something if you don't have the something? So it's assumed it's given to you. So here's a state diagram, state transition diagram of an automaton. So you start looking at it. Now some things about it are pretty obvious, like it's a 5-state machine, right? You have five nodes. Looking on this state diagram, state transition diagram, as a graph. Okay. Except for this, that would not be an element of a graph, part of a graph. But the rest it's all graph. So it's a directed graph. Okay, so it's a 5-node machine, or 5 states. Obviously, 5 nodes, 5 states. What else can we see immediately about it? It has 2 accept states. Two of the nodes have double circles, so we have 2 accept states. So this machine could terminate in this state, Q1, or R1. Okay, so there's 2 ways it can stop. It'll stop, but that it can give a decision of accept. Right? There's 2 ways it can accept. By terminating in state Q1 or terminating in state R1. Okay? So 2 accept states, Q1 and R1. What else can we say? All these transition labels, they're A or B, so it looks as though the alphabet, I remember, which I got wrong before, what's an alphabet? It's the set of all possible allowed symbols that can appear in your input string. Okay, in this case, just 2, A and B, little a, little b. Okay? So you get these A's and B's all over. Okay, so that's your alphabet. So the input string will just consist. It'll be a string of A's and B's, effectively. Okay, that's it. Now, can you remember almost the technical term, like experimenting? What does that mean? That means doing trials, putting in input strings and trying to figure out what the function is of this automaton, its job, what's it doing. So trying to decide what kinds of strings will go into the set of all accepted strings. In other words, the language. In other words, what's the language of this thing? Alright, so do experimenting. I mean, you can try inputting different stuff. Now, what happens? Now it'll accept strings A and B and AA and BB and BAB. It accepts all those strings. Well, let's just do a few quickly. So A, what happens? A, and it terminates. Well, that's accept. B, sort of go this way. Well, that's also an accept state. So this string is accepted. AA, so A, so it's still in Q1, so AA is accepted. That string is accepted. BB goes this way and then back again, so remains in R1. That's an accept state, so BB is accepted. BAB, okay. BAB, so it terminates in R1, that's an accept state, so BAB is a string that's accepted. Now these strings, AB, BA, BB, BA, are not accepted. In other words, rejected. Okay, now why is that? Well, let's just loop through the automaton and see what happens. So A, B.